Solving sets of linear equations, there are three types of solutions, or three answers that you could get. The first one is a unique solution. That means that every variable corresponds to exactly one answer. So here I have my original matrix, and I change it into a reduced row echelon form matrix. And here I see that if this is x, x is equal to -9, y is equal to 10, and z is equal to -2. So there's only one answer for every single variable. The second type of solution we can have is no solution at all. So in this row, we see that we have 0x plus 0y plus 0z is equal to 2. Now, because this is not possible, it means this entire matrix is invalid and there are no solutions to it. Now, the last one is an infinite amount of solutions. So this happens when we only have 2 rows left at the end, but we have 3 variables. Same thing if we have like 4 variables and only 3 equations left. And so what happened was that this last row is zeroed out. So it doesn't give us any information. Here we have y plus 2z is equal to 3, and x plus 2y plus 3z is equal to 4. There are an infinite amount of solutions for x, y, and z here. Let's just go over an example for each and every one of them. We're going to be using this variable k, and we want to find what k is. So you might have questions like this on tests or an exam. Now, the question would be, find k so that this set of linear equations has a unique solution. Meaning, what is k so that x is one specific number and y is one specific number? Now what you do, like always, is we put it in an augmented matrix form. So here we have 1, 2, 2, 4, and instead of putting 1, because it's 1y, it's 1k, so we can just write k, and we have 6. Now what we want to do is we want to know what y is and what x is. So this whole column is the x's and this is the y's. So to do that, we need to get rid of this 4 here because it's not going to give us any information, just as a 4. To do that, we take row 2, this entire row 2, and that's equal to the old row 2 minus 4 times row 1. So 4 minus 4. Here you see that I did k minus 8. That's because k minus 4 times 2 is 8. And I just write it like this in the matrix itself. Same thing here. 6 minus 4 times 2, 6 minus 8 is -2. With this information, I can just rewrite this entire row into an equation form. So k minus 8 times y is equal to -2. That's what this row means, right? Because this is the coefficient of y. Now, if I want a unique solution, then this has to be a number. I have to have, say, 3 or 4y. I have to have something there. If k were to be 8, I'd have 8 minus 8, which is 0 times y, is equal to -2. That would be no solution at all. So k cannot be 8. It can be any other number. Let's say k is equal to 10. 10 minus 8 is 2, so 2y is equal to -2. I know what y is. I can find out what x is. Alright, next we want to figure out what k would be for this set of linear equations to have no solution. I take my set of linear equations and I put them into a matrix form. Again, you can pause the video, see if you can do this yourself. And now I want to make this entire bottom row zeros, because remember, if it has no solutions, it means that this will be a 0, this will be a 0, this will be a 0, but this here, this 10, will be a number. I don't know what number it is yet. Okay, let's just start as if we were doing a row echelon for it. I take row 2. My new row 2 is equal to the old row 2 minus the old row 1. Here 1 minus 1 is 0, 2 minus 1 is 1, minus 3 minus 5 minus 3 is negative 8, 1 minus 0 is still 1. Next, what I want to do is continue with my row echelon form. So I want to take this 7 here and I want to make it a 0 instead. So I do my new row 3 is going to be equal to my old row 3 minus 7 times my row 1. 7 minus 7 is 0. 16 minus 7 is 9. K minus 7 times 3 is k minus 21. And again, I just write it out here. 10 minus 7 times 0 is still 10. I do row 3 minus 9 times row 1. Sorry, minus 9 times row 2, which is this row. 9 minus 9 times 1 is 0. K minus 21 minus 9 times negative 8 is k plus 51. 10 minus 9 times 1 is equal to 1. So we have x plus 51 times z is equal to 1. Now remember, to have no solution, these three first numbers have to be 0, and this number on the right has to not be 0. So to make k plus 51 0, k has to be negative 51. So negative 51 plus 51 is 0. 0 times z is still 0. 0 is equal to 1. That doesn't make sense, so that has no solution. So the last thing we are going to be doing is finding out how to make this augmented matrix have an infinite amount of solutions. As we see here, we have two variables. We have x and we have y. If it has infinite amount of solutions, it means that one entire row is zeroed out, so it's full of zeros, and then I have two variables in the same row. Let's just do that. To make this whole row a 0, I'm going to do the new row 2 is equal to the old row 2 plus 1/2 of the old row 1. So k plus 1/2 of 4 is k plus 2. I wrote it here. 1 plus 1/2 negative 2 is 0 because it's 1 plus minus 1. Now, negative 3 plus 1/2 6 is also 0. Here I have this row is almost all zeroed out, but what's left is my k. So k plus 2 times x, because it's in this first column, I need it to equal to 0. How do I do that? Well, if k is equal to negative 2 plus 2 is 0. 0 times x is 0. And when I do that, my entire row is full of zeros, and I'm just left with one equation with two variables. So that's it for my equations. The next video is going to be all about symmetry and the identity matrix.